In this video, we are going to study trigonometric functions. We know that basic trigonometric ratios are defined for acute angles in a right-angled triangle. But we know that every real number corresponds to an angle measure in radian. Therefore, trigonometric ratios for any angle in radian measure correspond to a unique image in codomain of set of real numbers R. Therefore, we study trigonometric ratios as trigonometric functions for any angle in radian measure. Hello friends, you are watching YouTube channel Number Collage. This channel features videos on mathematical concepts. Effort has been made to explore the concepts through basic mathematical ideas. Hope you will like my effort. Consider this unit circle whose center is at the origin of xy coordinate system. Let us denote the points of intersection of this unit circle with the coordinate axis. With positive x-axis, the point of intersection is A, whose coordinates will be 1, 0. With positive y-axis, point B, whose coordinates will be 0, 1. With negative x-axis, coordinates of point C will be -1, 0. With negative y-axis, point D, whose coordinates will be 0, -1. Let us take a point P, A, B on this unit circle so that radius OP will be of length 1 unit. Let length of arc AP be of length x so that corresponding to this length x, angle AOP will be of measure x radian. Let us draw a perpendicular from P on positive x-axis PM, and since coordinates of point P are A, B, length OM will be A and length PM will be B. Now in right triangle PMO, cos x will be adjacent side OM upon hypotenuse OP, A upon 1, which is A, and sin x will be opposite side PM upon hypotenuse OP, P upon 1, which is B. According to Pythagoras, A square plus B square equals 1 square, which is 1, that is cos square x plus sin square x equals 1. Now complete revolution about center of unit circle O subtends an angle of 2 pi radian. Quarter of this revolution is angle AOB, which will be 1 pi by 2. Half of this revolution will be angle AOC, which will be 2 right angles, that is 2 pi by 2. 3/4 of this revolution will be angle AOD, which will be 3 right angles, that is 3 into pi by 2. Since these angles are integral multiple of pi by 2, they are known as quadrantal angles. So for these quadrantal angles, we have cos 0 is this 1, sin 0 is this 0, cos pi by 2 is this 0, sin pi by 2 is this 1, cos pi is this -1, sin pi is this 0, then cos 3 pi by 2 is this 0, sin 3 pi by 2 is this -1, cos 2 pi is again this 1, and sin 2 pi is again this 0. We observe that cos 0 is 1, and after one complete revolution cos 2 pi is also 1. Similarly, sin 0 is 0, and after one complete revolution sin 2 pi is also 0, which means that the values of sin x and cos x remain same after an integral multiple of 2 pi. Therefore, cos of 2 pi n plus minus x is same as cos x, where n is an integer. Similarly, sin 2 pi n plus minus x is same as sin x, where n is an integer. We observe that sin x is 0 if x is 0 plus minus pi, this plus minus pi, again this plus minus 2 pi, again this plus minus 3 pi, so on and so forth, which means sin x is 0 if x is an integral multiple of pi, 1 pi, 2 pi, 3 pi, etc. And cos x is 0 if x is plus minus this pi by 2 plus minus this 3 pi by 2 plus minus 5 pi by 2, so on and so forth, which means cos x is 0 if x is an odd multiple of such as 1, 3, 5 of pi by 2. Therefore, we can say that sin x is 0 implies that x is n pi, where n is any integer, and cos x is 0 implies that x is 2n plus 1, which is an odd integer multiple of pi by 2, where n is any integer. We have cosec x equals 1 upon sin x, where sin x should not be equal to 0, which means x should not be integral multiple of pi. Sec x is 1 upon cos x, where cos x should not be 0, for that x should not be an odd integral multiple 2n plus 1 of pi by 2. Tan x is sin x upon cos x, where cos x should not be 0 implies x should not be an odd integral multiple 2n plus 1 of pi by 2. Cot x is cos x upon sin x, where sin x not equal to 0 implies that x should not be an integral multiple of pi. Then only cosec x, sec x, tan x and cot x will be defined. We have seen sin square x plus cos square x equals 1, which we call our first trigonometric identity. For any real number x, we will process other two trigonometric identities from this first trigonometric identity. We divide this trigonometric identity by cos square x. So it will be sin square x upon cos square x plus cos square x upon cos square x will be 1 equals 1 upon cos square x. This will be 1 plus tan square x equals sec square x. So this will be our second trigonometric identity. For any real number x, in order to find the third trigonometric identity, we will divide this first identity by sin square x. So we get sin square x upon sin square x 1 plus cos square x upon sin square x equals 1 upon sin square x. So we get 1 plus cot square x equals cosec square x. So this is our third trigonometric identity for any real number x. Consider a point P, A comma B on this unit circle. In the first quadrant, A will be positive, P will be positive, which implies both cos and sine functions will be positive. And since both cos and sine functions are positive, all remaining trigonometric functions will also be positive. If the point P, A comma B is on the unit circle which lies in the second quadrant, then A will be negative and B will be positive, which means cos ratio will be negative, sin ratio will be positive, cosec ratio will be positive, and remaining functions will be negative because they involve negative cos. So in the first quadrant, all trigonometric functions are positive. In the second quadrant, sine and cosec functions are positive and all remaining functions are negative. If the point P, A, B lies on this unit circle in the third quadrant, both A and B will be negative. Therefore, both cos and sine functions will be negative. Therefore, tan and cot functions will be positive because they involve both negative cos and sine, and the remaining functions will be negative. So in the third quadrant, tan and cot are positive and all remaining functions are negative. If point P, A, B lies on this unit circle in the fourth quadrant, A will be positive and B will be negative. Therefore, cos will be positive, sine will be negative, sec will be positive, and all remaining functions will be negative. So, in the fourth quadrant, cos and sec are positive and remaining trigonometric functions will be negative. So, this is the sign convention of trigonometric functions in different quadrants. Let's revise the sign convention. In the first quadrant, all trigonometric functions are positive. In the second quadrant, sine cosec are positive. Remaining functions are negative. In the third quadrant, tan cot functions are positive. Remaining functions are negative. In the fourth quadrant, cos sec functions are positive and remaining functions are negative. This can also be remembered starting from first quadrant, all, and moving anticlockwise S, T, C. Friends, if you like this video, please click the like button. Share this video with your classmates. Don't forget to subscribe this channel. Make constructive comments to help improve my videos. See you in the next video. Until then, keep watching Number Collage. Thank you.